going to be looking at the Ready to Teach lesson called Struck Gold, a Density Investigation. And we are going to cover three objectives: navigate and understand the data table, create and manipulate graphs, and create and interpret a regression line, also called a line of best fit. My name is Nigel Standish, and I'm the Director of Operations for DataClassroom. I started teaching in 2001. I was a math and science high school teacher in Tennessee, California, and Virginia. I have also taught survival for Uncle Sam in the Air Force as a SEER specialist, and then most recently worked for the Charlottesville, Virginia City Public Schools as their Director of Science and Engineering. I am excited about DataClassroom. I was fortunate enough to pilot an early version of DataClassroom in my science classrooms in Charlottesville, and I've seen firsthand some of the wacky, wonderful, and crazy things that can be done when students are given tools to easily analyze and visualize data. Just a quick aside, this afternoon I was talking with an 8th grader and their teacher, and she had run an experiment where she fed beetles different types of beans and then measured which ones were alive every day for over 2 months. And it was just amazing to look at that data set and see how excited that young lady was about her experiment and creating graphs for her experiment and seeing the differences and connections and relationships. I have put the Google Doc for tonight's lesson in the chat. If anyone can't see that, just pipe up and I'll put the link in again. Let's do a quick technology check. Everybody should be able to see the DataClassroom dashboard. This is the dashboard that you arrive at when you first log in. We're going to go up to the resource library. Oh no, you can see that I was practicing. The resource library will look like something like this. And we'll type in gold. And we'll find our Struck Gold, a Density Investigation, RTT. I'm going to click Open the Data Set. And that will take me to the table view. No worries there. Oh, thanks, Laura. Appreciate it. Will take us to our data table. And if we take a look at our data table, we'll see that there are three main tabs across the top: the table tab, the graph tab, and the assignment tab. Really quickly, I'm going to click the assignment tab. This is where the Google Doc for the lesson lives. It's not the tutorial version that you all have tonight because we just finished writing that and haven't made it live. Each of the assignments for the RTTs has a little background, some description of variables, and then an activity that you or your students can walk through. But if we go back to the data table view, you're going to notice that the variables are housed in columns. This data set only has 3 variables: rock type, which is a categorical, mass, which is a numeric, and volume, which is a numeric. Also on the far left, there's a column that just has the row numbers. We can scroll down and get a quick idea that this data table has 20 different observations with 3 variables for each observation. We're going to jump right into the graphing tonight by clicking on the graph tab, and we're going to see those same 3 variables show up at the top of our screen. And we're just going to click Show under Rock Type. I think that one of the most powerful ways to get into a data set is by visualizing it as soon as possible. And so we can see that right away, this graph that we've made with rock type shows us there's 5 different rock types, each with 4 rocks in each group. Now, we could get that from our data table by counting, I said that wrong, each with, did I say 4 rocks in each one? Yes, so we can get that on our data table by counting under rock types A, B, B, but it's much more appealing to see that visually in a graph format. We'll get right into a different graph by clicking on mass. And here we can see DataClassroom put our categorical variable, rock type, on the x-axis, which is standard practice, and put our numeric mass on the y-axis. If you have this graph pulled up, one of the things, the lesser known ways to view this data is by hovering over each of the dots, and you get a row number and a exact numeric for the y, which is mass. So we can see that this data point that I'm hovering over has a mass of 320 and is located in row number 4 of our data table. One of the ways to encourage exploration in a data graph like this is just by asking things like, well, which rock and what rock type have the least mass and the most mass? And I can visually see along the bottom here that this rock in type A has a mass of 40, and this rock in type C has a mass of 1,376. A more advanced brain teaser is these rock types were all grouped visually. That is to say that somebody looked at the rocks and said, hey, these 4 rocks look the same, these 4 rocks look the same. But now that we have the ability to graph and visualize their mass, would you group them any differently? Do you see 5 distinct rock types when measured by mass? And for me, I would say probably no. I think that I might group them in a group of 4, maybe below 200, 200 to 400. This group here, which is kind of 400 to 800, and then maybe this one, these 2 up here, but maybe only even 3 types. I'm going to click show on our final variable here, volume, and you'll notice that our graph didn't change at all, but over here on the right in our variable control panel, volume was added, and we are able now to make some choices with it. If we take a look at our control panel, this is kind of the nuts and bolts of our graphing choices. We have our type of graph options, whether it's pie charts, rectangle-based graphs, or dot plots. We also have the ability to change the appearance of our graphs here. For example, we can change the type of dots, the color of dots. We can exchange our dots for emojis. We can change the point size to make them smaller. We can increase the edge widths to make them a little more bold. And we have many different appearance options in this menu. Under the columns, you'll see that for rock type, X is highlighted red on my screen. And that's because it's currently being displayed on the X-axis. Whereas mass, the Y, is highlighted red because it's on the Y-axis. Instead of having mass on the Y, I'd like to visualize volume on the Y. And so I'm just going to click the Y button on the volume variable. And you can see in an instant now I have volume on my Y while rock type remains on the X. I'd like to ask the same two questions. Which rock type has the rock with the least volume? And which rock type has the rock with the most volume? And just with a quick visual inspection, we can see that in rock type E, in group E, we have a rock that has a volume of 79 centimeters cubed. And in rock type C, we have one that has a volume of only 7 centimeters cubed. Now that we've displayed three graphs, I'd just like to pause for a second. And since we are a small group tonight, if anyone has any questions up to this point, let's ask them. All right, no worries. Did everybody get access to the Google Doc? I'll just paste that one more time. I think it's interesting for both the rock type and volume and the rock type and mass that there weren't clear delineations for grouping. The volume, I think, is even more muddled than the mass. We don't really get any clear breaks horizontally here of how we might have grouped our rocks differently. But that changes when we look at volume and mass. You can see that I put mass on the X and volume on the Y, and the graph that I get's kind of skewed to the left. So I'm going to very quickly, by clicking on X for volume, switch those down and get a graph that's more visually appealing. You can see here, now we're starting to get more relationship vibes. We can see we have this cluster of data points right along here in the middle. We kind of have these outliers down here, and we certainly have this group of 4 clearly has a different relationship in mass and volume than these others. What we don't know is, does it have anything to do with the type of the groups that we put the rocks into? And we've already used up our X and Y. So for rock type, we're going to put that on Z. And DataClassroom automatically colors and labels a categorical variable when you put it on Z. So you can see A is purple and so on and so forth. And now you can see, well, visually, we put rock type C, these 4 rocks, into a group. And also mass and volume relationship, they look like they belong in a different group than this. One other way to visualize each of these is by doing so separately. And with a categorical variable next to its variable type, you'll have a button called values. Those values, when you click on it, will give you the option to change the label of each of those categories to change the color, to change the type of dot, to change the order. And then tonight we're going to look at the exclude option. So I'm going to exclude A, which is this purple one, and C, because they seem to be a little different than the others. So I'll exclude A and C. And you notice now I get quite a small grouping of rock types here. And if we ask that same question that we did for the other two graphs, how would you group these rocks differently if you knew their the mass and volume, or you were able to look at the graph? You might have decided to group all of these rocks in the same. But just because things look a certain way doesn't mean they are, which is why we have an interest in teaching our students about data. And so we're going to click this regression line right here, and that's going to pop up a line of best fit for each of our rock types. And it's also going to give us the equation and the slope for each of them. So if we take a look at the slopes here, we can see that for B, 8.66, D, 8.375, and E, 8.582, while very similar, not exactly the same. And this data set is interesting because the mass and the volume have an interesting relationship with the slope, because slope is rise over run, which for this graph is mass over volume, which is also the formula for what in science and math? It's density, right? Density equals mass over volume. So in this particular instance, our slope is the density for each rock group. I'm going to go back to values, and I'm going to allow groups A and C to join the party. And again, we get a view of our 5 rock types and their slopes in relation to each other. It's interesting to note that in this case, it looks like our regression lines are crowding out our data points. And so we have a couple options here. We can go back and we can increase our point size here, but we can also go down to our regression line and reduce the regression line width. So just to give us a better idea. And, another question that we might ask is, well, this regression line is a line of best fit, but are there any data points that are outliers, that are falling quite a ways off of the regression line? And we can see that all of them are fitting fairly well. I'm looking a little bit at this pink one right here, which is in group B. So I want to take a closer look and exclude the others. And I can see there's a couple data points falling a little ways off the regression line. I might want to have a small conversation about outliers and what line of best fit actually means, and encourage just some thinking around those things. Let me bring everything back by unexcluding the rest. In this lesson in particular, we provide the density measurements for the 5 common the 5 rocks that are commonly mistaken for gold. And so at this point, understanding a slope is right now mass over volume, which is a measure of density. I can go back to my assignment tab and I can look at these 5 types of rocks that are commonly mistaken for gold. And I can look at their density measurements and compare them to the densities of the rock types in my graph. And I can see that rock type C has a density very similar to that of gold, while these others have densities that are similar to the other rock types. If I'm working on an assignment and I feel like I've reached a point that I want to document the graph type that I have, I can click this camera icon, which will display the graph. I can click copy. I can bring it over to my assignment, find the question that it uses, and just paste it in. And of course, that will work for Sheets or any of Microsoft's products, and is a nice way to translate. Oh, I didn't share this tab. There we go. Now you can see how easy it pastes into other docs. When we are first getting started with DataClassroom, I think it's really important to focus on the visual aspect and the ease at which data can be visualized in different types of graphing ways. But it's also important to recognize that a machine has to recognize the data table in order to have that ease of graphing. And one of the most common hiccups, especially when collecting student data, is formatting it in a way that a machine can understand, or the DataClassroom. And so I just want to quickly just iterate some common missteps that I see when helping students format their data in what we call tidy data format. So very often I will see a data table that has this in one table, like just this A rock type, and B rock type will be in a completely separate table. And you can see that for this exercise, we created one column, one variable type, one variable that is just called rock type. And we included all of the rock types within that one column and included the observations for mass and volume in separate. That allows a graphing program like DataClassroom to put all the rock types into one graph. Whereas if we kept it separate in different columns and had, instead of maybe 20 rows, we had 20 columns, then we would only be able to look at one rock type at a time instead of having them all on the screen at the time. One way to look at it is just thinking, what's the simplest columns that I can put my data into, and trying to tidy format data is often called long data because it doesn't have very many columns, but it's often quite long in the rows. That is the walkthrough of the RTT struck gold density investigation.